Number 8. A central station has an annual factors as follows: load factor 58.5%, capacity factor 40.9%, use factor 45.2%. The reserve carried over and above the peak load is 8,900 kilowatts. Find the number of hours per year not in service. The hours per year not in service is equal to 8,760 hours less the number of hours operation. Solving for the number of hours operation per year, we have the formula of capacity factor is equal to the average load times 8,760 over the installed capacity times 8,760, or is equal to the average load over the installed capacity. The formula for the average load is equal to load factor times peak load, and the installed capacity is equal to peak load plus reserve. The capacity factor is equal to the average load factor times peak load over the peak load plus reserve. The capacity factor 0.409 is equal to the load factor of 0.585 times the peak load over the peak load times plus reserve 8,900. Then the peak load is equal to 20,682.38 kilowatts. The installed capacity is equal to the peak load 20,682.38 plus the reserve 8,900 kilowatts is equal to 29,582.38 kilowatts. The average load is equal to 0.585 times the peak load 20,682.38 kilowatts. The average load is equal to 12,099.19 kilowatts. The annual kilowatt hours is equal to 12,099.19 kilowatts times 8,760 hours per year. The annual kilowatt hours is equal to 105,988,000 1,924.5 kilowatt hours per year. Use factor is equal to the annual kilowatt hours over the installed capacity times the number of hours operation. 0.452 is equal to the annual kilowatt hours 105,988,924.5 kilowatt hours per year over the installed capacity 29,582.38 times the number of hours operation. The number of hours operation is equal to 7,926.63 hours per year. Then we can now get the hours per year not in service is equal to 8,760 less 7,926.63 hours per year is equal to 833.37 hours.